Okay, now let's run the same data in Caret with several tuning parameters. Okay, and then remember we need to use nnet because this is a classification problem. So the first thing to do is to set up our grid. So my grid. So we need to use expand dot grid, and we have so the first one is decay equal to, so we will use 0.5 and 0.1 for decay, and then size dot size equal to C 5 to 7, 5, 6 and 7. Okay, so run that, and then we have our my grid set up. Okay, check it out. Alright, so then we do the training. So we'll call that nn.acc.cr for caret. Okay, so that we use train, and we specify the formula. Okay, and that is max severe IR. Okay, and against all other variables. Okay, now max severe IR has to be a factor, and it is already a factor. We set that up earlier. So data equal to accident train. Okay, then we have method equal to nnet. Okay, tune grid equal to my grid. Alright, now trace equal to false. Okay, so there is one other parameter that is important in when you have missing data and you have not imputed the missing data, then NA action is NA omit. Okay, so that may be needed sometimes, but you don't want to leave the missing values as is. Usually it's preferable, or more than preferable, it is definitely very desirable to impute missing values and make sure that we get to use all the data and not throw any data out. Okay, now run this. Okay, so now it's gone through all the iterations, and then it's given the results. So now if you do nn.acc.cr, okay, so that's the object where the results are kept, and here we get the tuning parameters used, decay and size. Okay, decay is the factor used for updating the weights. Size is the number of neurons in the hidden layer. So each of them gives you the accuracy value and kappa, and accuracy is the default that's selected with which the best tuning parameters is selected. So that's the one that will be used for prediction and so on. So now let's develop the plot, and since this is nnet, we have to construct the data that we need, which is that. So we need to make some changes. Okay, we will make those here. Okay, so now weights. Okay, so weights should come from nn.acc.cr, and then the structure should come from nn.acc.cr. So the input names now are the column names. right? So instead of um, typing out everything, we'll just say capture the column names here, call names of what? Accident valid.df or train.df. Okay, but except there is one problem here. The input names should be only predictor names. And if you run that, your input names is going to include the eighth name is going to be your target. So if you now say input names 8, okay, so it's give you maximum severity. Yeah, so we don't want that eighth name as a, we don't want that as an input variable name. So we need to specify input names equal to, or set it to, we don't want, okay, so input names is input names, we want -8, right? Now instead of doing -8, suppose you want to make it more flexible or more reusable code, then we can say, okay, we take the length, okay, so length of input names, okay, so length of input names will give you how long that list is. So it's going to say 8. So minus length of the input name would translate to -8. So the eighth one will be gone. So if you run this code and you see input names, okay, you have 1 to 8 and gives you the list, right? So when you run that, it'll become 1 to 7. Now you want to be sure, then you just run that part and you see the names here. Okay, it doesn't include the target. So now the output name is max severity IR. Okay, so okay, I don't know whether I ran these two, so let's go ahead and run these two, and then okay, so here is the network, so 3 levels of severity, and here are the input parameters. And then remember, the gray means negative weight, dark, these colors can be changed in the procedure. There are options for that. So these are the bias, these are the hidden neurons, 5 neurons is what is 5, 6 and 7. Remember, it's chosen 5 as the best. Okay, then to, if you want confusion matrix, then we have to set up the probability first. Okay, probability dot ACC-CR, right? Call it, yeah, CR. Okay, predict nn.acc.cr, and then new data is accident valid. Okay, and then we say type equal to probability, and that generates, okay, that. So we have the 3 probabilities, and then we need to run the apply. Okay, so pred.acc.cr will be, okay, apply, right? We want to take the probability which is there, and you want to go row by row, and then which max. And of course we want to do a -1 to make sure that, so those are the predicted classes, pred. Okay, so now we are ready for confusion matrix. So confusion matrix would be, okay, we need to do as factor for the predicted class. Okay, so that's the predicted class. Okay, and then the actual class. Okay, so actual class max severe is already a factor. So then you have the confusion matrix.